And let me tell you how I won the Feynman Prize. I taught a class where one member of the class wrote a nomination letter, and every single member of the class wrote supporting letters, which would be really impressive, except that there were 4 people in the class. And they were told there was really no hope of getting a Feynman Prize for a nomination for a class with only 4 people in it, but it worked. And this goes to show that indeed teaching a seminar class well is a distinctive skill and a very important part of teaching, and also from the student point of view, a very important part of your education. Right? So when I was asked to give a CPET talk, I said, well, geez, I don't know anything about teaching. I'm now the official teaching expert because I won the teaching prize, but I've never, in my entire career, taught a class with more than 15 people in it. Right? You might be the record. I will in the spring be teaching GE1, our big freshman class, so I better get my act together. But meanwhile, this is what I know how to do, actually, pretty well, is teach small classes of graduate students and try to do something special with that class that makes it more than just a small lecture class. So that's why I call this lecture Making the Most of the Ratio. You've already got a small ratio if you're teaching a seminar class. That's great, and that will inherently allow you to do more than you ever can with a big lecture class. But how can you do more than more? That's what I'm going to try to talk about today. So let me start with my slogan. If you're going to teach, especially if you're going to teach about teaching, then teach by example. Right? So you will sometimes go to seminars on teaching, and somebody will get up and teach you about teaching, except they're a lousy teacher. And that's not very inspiring. You don't learn very much from that. Right? I'm going to try to run this seminar the way I would run a seminar, and the way I would want you to run a seminar. And we'll see how that goes. Okay. So the most important thing about any kind of teaching, really, okay, is you have to teach the right amount of material for the audience before you and for the amount of time allotted. Okay. If you teach too much material, you might say, okay, I'm teaching a class on, I don't know, what are you most likely to teach a class on at some point in your career?
Mechanics of materials.
Mechanics of materials. There's a lot to know about mechanics of materials. There's a lot of kinds of materials, there's a lot of underlying knowledge, right? If I'm going to teach this class and my students are going to come out knowing about mechanics of materials, I've got to cover a certain amount of material. Right? And it's very easy to get into that mode and put too much material into a class. And I happen to believe that that's a mistake. That when you put too much material in, the students don't retain it beyond the test, they don't like it, and they're not likely to come back for more. Right? Now, of course, too little material is also a problem. If you have 10 weeks in a semester and you don't get past the basic introductory material, you've wasted the student's time. Okay? However, I think, at least for me, and probably for a lot of people, when you're designing a class, it's much easier to overdo it with too much material. That is the pressure that you need to fight against. Okay? And so the only way I think you really can communicate too little information in a class is if you waste everybody's time because you're not organized, or if the bit rate of your oral communication is too slow, that you only manage to get 10 sentences out. On that note, actually, here's an anecdote. When I was a pre-frosh, I visited Harvard College, and my brother took me to see the great political philosopher John Rawls give a lecture. This guy is a giant of 20th century political philosophy. His book, A Theory of Justice, is read in every political philosophy class. Well, John Rawls has a really, really serious stutter. Okay? He can barely get a sentence out. He could barely get a sentence out. He's passed away now. And yet, hundreds of people came to this lecture to hear him talk. But I don't think they got anything out of it. I think what they got is they read his book and they wanted to see the author of the book. So it is possible to give too little information, but it's hard to do it. My other hypothesis that's related to this is many of us are afraid of boring our students. Like if we teach at too low a level, or if we don't teach enough material, they're going to be bored. I don't think that's true. In fact, in my experience, people really like being taught things that they already know. It makes them feel good. Especially, by the way, if you have any oral exams coming up, any of you in graduate school, your professors love being taught stuff they already know. That's what they're there for. That really makes them feel good. You want to give a new spin, a new perspective on material. But there's a lot of material that needs to be taught more than one time. Thermodynamics, for example, subject of my research. You just don't get it the first time, no matter how well it's taught and no matter how smart you are. It's just too obscure. Second time you learn it, it starts to make sense, and then you put it in practice and it works. So pitching a class too low is actually difficult to do, okay, and isn't necessarily bad. If you can fill in gaps and you can give people new perspective and you can give them practice and you can make them better at what they're doing, okay. As an example, teaching this by example, okay, I've got about 60 minutes here. If I were giving a 60-minute science talk, I would put 60 slides in my lecture because there's a certain amount of material I want to get through in order to make everybody in the audience hopefully understand my research, and I'm going to make the most of that hour. Okay, my presentation here, I've got 12 slides to fill an hour. And so I'm intentionally under-programming this material for a couple of reasons. One, I don't want to go too fast because I'm trying to teach by example about not going too fast. Two, at some point I want to get off the screen and out into the audience and get you guys to start participating. And if I have too many slides, that's not going to happen. So there's only a few, and the other thing is, I don't know that much about teaching. I don't have 60 slides worth of stuff. I just sat down and thought about how do you give a good seminar, and I came up with about 12 slides worth of material. Okay? And this is an important thing to think about. Why is the Caltech Project for Effective Teaching an important thing to do? Okay? I'm a professor at a substantial research university, and here's what your job description consists of when you're a professor. Okay? It's about 1/3 at most doing research. It's about 1/3 teaching, which includes both classroom teaching and advising graduate students. It's about 1/3 managing personnel, be they your staff or your students or whoever. It's about 1/3 financial administration. Once you get a grant, you've got to actually keep track of where that money goes. It's about 1/3 grant writing. And of all those thirds, the only one that most of us are actually trained in at all is doing research. As far as teaching and financial administration and proposal writing and personnel management goes, we're all faking it most of the time, right? And that's not ideal. So Caltech Project for Effective Teaching is one way in which you guys who have shown your interest by showing up realize that if you're going to be a professor, if that's your career goal, that teaching is an important part of that job, and teaching can be done well or it can be done poorly. So, I just stole these pictures off the web somewhere, but when you think about teaching, okay, most of us probably think about a situation like this. This is what teaching is like in most universities most of the time. Okay? At least in this case, these students are all actually looking at the front of the room. None of them seem to have their phones out. None of them seem to have their laptops open.
Not candid.
They're all kind of leaning on their arms. Then we have classes like this, right? 4, 5, 10 people sitting around a table, the professor not up at a podium. Okay? And certainly given the choice between teaching a class like this and teaching a class like this, I'm going to teach a class like this if I get to choose. I think that's probably true of most of us. If you have an opportunity to teach a seminar class, you should take it. You can do more with it, you can get to know the students, you can secretly recruit them to join your research group or whatever. We don't all have that chance, okay? Because there is something to be said for a big class. It's much more efficient. You can deliver your message to a lot more people in the same amount of time, and the same effort. And sometimes there are a lot of people who want to hear your message. Okay? But the seminar, on the other hand, is fun and exciting and challenging in a different way. And since it's something that if we all have an opportunity to do, we would all like to do, it's something we should think about how to do well. And on that note, okay, how you do it well. I think there's one key, there's one thing that a seminar class can be that is very difficult to do with a lecture class unless you're, used to be, I would say, unless you're Phil Donahue, and that shows how old I am. unless you're over free. Interaction. Okay, that's the bottom line of what a seminar class can be. It's an opportunity for everybody to participate. Okay. Because a lot of what people learn about from a class is not just what they read in the book or the material that you teach them. It's how to speak up about the material, how to form an opinion about the material and express it, right? How to argue a point of view with other people. And also interaction in class, getting people to talk back to you, okay, does several things. First of all, I think it's a much more effective means of evaluating whether people are with you than giving them tests at the end of the material. It's very real time. Does that even better than iClickers where you have to make multiple choice questions or something like that. And at least for me, if I can get a class to talk back, right? If I can get them to get over the barrier of, okay, he's the professor, he knows what he's going to do, he's going to talk for the next hour, and I'm going to sit and listen, right? If I can get over that barrier, the whole experience becomes more fun for me and for everybody, right? So, okay, and somebody should interrupt me at this point. Right? Somebody should say, no, I disagree. Students who raise questions are always wasting your time and slowing you down, and you can't get through the material, right? Students, they never know what they're asking or why they're asking it. You should just tell them what they need to know. Stop me anytime I say something wrong. This idea, I'm not sure this is quite the right kind of interaction, this little clip art here. But this is what you can do with a seminar class, and this is what you have to do. You have to get people to participate. And so here are my 4 strategies for maximizing interaction. Okay? Yes?
One second. So you satirically gave a point of view that probably you don't agree with. So what is your best argument against that? When you talk with people about how you should have interaction, you should find out if the students are following, and someone says no, that will slow you down. You will not be able to present as much information. Your peers won't think you're as cool, et cetera, et cetera, et cetera. What is your best argument against that?
So my best argument is, if you're just presenting information without any feedback as to whether the information is being absorbed, you're just spilling information on the floor. If you're actually handing somebody information and they're picking it up and they're processing it, they should be able to interact with you about that information. And in my experience, the people who should think you're cool when you're teaching are ideally the students that you are teaching. And your colleagues will think you are cool if you are able to teach classes where the students think you are cool.
Yeah.
So, no, I think going back to my earlier point that it's easy to teach too much material and it's hard to teach too little material. Saying, no, I can't slow down to take questions, indicates obsession with trying to get through the material without necessarily making sure everybody is following the material. That's what I meant when I put that straw man out there.
So you talked about thermodynamics. Please
Yeah.
ask us to interrupt. So you talked about thermodynamics as something that people So how do you have a discussion with people who are seeing it for the first time, possibly the very first in that class when you haven't necessarily done it? What do you discuss with someone who's just seen, you write delta H on the board?
That's a great question. If at any level, I think when somebody is learning material, if they're thinking about what they're learning, there should be questions. Okay, I write delta H on the board. I say, could this symbol means enthalpy of formation? Somebody should say formation from what? Somebody should be thinking right at the beginning, why do I care about enthalpy? If you're about to explain why it's a
Have you
significant
ever had a
variable.
student ask you, why should I care about things?
Well, most students are afraid to do that, right? They assume that if they're there and I'm teaching them about it, that they should care. Okay? Which actually is the secret behind the second point that I'm going to get to. And the thing, of all the things that I've done in teaching, the thing that is most distinctive, okay, is that I think you can and should let the students help to choose the material that they're going to learn. Then you get over right away the watching issue. In some cultures, especially when you watch teaching of children, the mode that you see is people ask dumb questions that they obviously know the answer to, and they're pretty sure the child knows the answer to, right? You know, I don't know if I have a good example, but if I walk up to a kid and I say, "What's this?" That's the answer you'll get in some cultures. In others, you'll get a blank stare, which basically means, duh, that's a napkin, and you know it's a napkin, why are you asking me that? Right? So when you're teaching undergraduates, I think if you try to get them to participate by asking questions that are lame, right? That they know you know the answer to, you don't get very far. I think open-ended questions work better and encourage students to ponder the answer and ask it and not feel like they're just being manipulated. Okay? So here's the outline of what I want to do with the rest of our time. Okay? I think the first thing, which is most important and also most difficult, is to establish an environment where almost everyone is comfortable contributing. Okay, there are always going to be, I'm teaching to this side of the room too much, there are always going to be people who are shy and are not going to speak up no matter what you do. Okay, there are going to be people with language difficulties, there are going to be people with behavioral issues, okay? There are going to be people who are going to be silent partners, and that's okay. But the better a job you can do establishing a class, a space, which is comfortable for everybody, okay, the more interaction you're going to get. And there are some, well, we'll get to how you do that in a moment, but that's the first thing that I think you have to do if you're going to have a good seminar where people are going to play along and do more than just sit and listen. Okay? This is the most challenging and novel of the steps that I'm going to recommend that you try. Okay, I've tried it, and it works, and it's excellent, which is let the students help you choose the material that you're going to teach them. That guarantees that they're learning the material they want to learn, and makes it very difficult to, teach a class that they're going to find irrelevant, or teach a class that they're not the right audience for. In a reading class, a lot of what you do is read literature, science papers, or if it's literally literature, you read literature, but here we're talking about scientific literature, okay? And that's hard because most people who are writing science papers are not writing material that is intended to be used for teaching. They're writing material that's intended to put their new results out before the professional audience. And so it can be hard to find papers to read in a group that are at the right level, that are going to effectively communicate the material. That's a challenge, okay? And finally, and this is related to all this other material, I don't think you want to teach a seminar class where it's like a little lecture class where the professor is doing all the talking. You want the students to participate as much as possible or as much as productive. Let's put it that way, right? If the students don't know anything and don't have anything to say, and you spend all your time waiting for them to say it, not very much will be said. So there is a balance to be found. Not always an easy balance to find. So let's begin with trying to make your class, your students, comfortable speaking up. Okay? This is a goal. It's not really a strategy to achieve that goal, and there isn't any one strategy that's always going to work. Okay? So here are some ideas. Okay? First is learn their names. In a class of 10 people, you should be able to get all their names in the first class, right? Now, I can cheat here. I know 3 of you and 4 of you already, but 5 actually. It's worth the effort, okay? In a similar perspective, this is not for everybody. This might not even be allowed at some schools, but I don't see that there's any real advantage to making you guys call me Professor Asimow. Okay? I ask my students, I encourage my students to call me Paul. And around the geology division, I think everybody thinks of me as Paul. And there's a cartoon that I used to have on the bulletin board outside my office. It said what to call your professor. And it was kind of a flow chart that took you through whether it was okay to call your professor by their first name, and it had questions like, is he from California? I've gotten drunk with him at a conference. My students, yes. And finally it ends with, wait, are you an undergraduate? It's too bad. But, you know, if you are trying to set up a learning environment based on informality, based on participation, based on everybody being a partner, it just does not help to have some people be children and some people be adults, some people be addressed informally and some people be addressed. Likewise, I think it's a good idea to be a person when you're teaching and not simply a teacher. Right? People are more comfortable, hopefully, speaking with you if they have some idea about who you are. Okay? So it's especially if in a seminar class where you would like the students to understand that the material they are learning is going to be useful to them in their career, it's not a bad idea to start out with how you have used this material in your own career. Right? So if I'm teaching about thermodynamics, it's what I do for a living. Right? And thermodynamics is important to me, and I wouldn't be able to solve the science problems that I do if I didn't use thermodynamics. Now that's not very personal, but you'll remember that I also started out by talking about my daughter. A calculated trick. Another thing to do, good thing to do with your first class, okay, in a semester or in a quarter, okay, is make sure that it's easy enough that everybody gets it. Right? You don't want to jump right in with your hardest material. So I teach a lecture class for the first year graduate students in mostly the geophysics and planetary science students. The class is on geology and geochemistry, all crammed into 10 weeks. It's a lot of material, as Giza will testify, as Rachel will testify, as Emily was TA to testify. And I used to do geochemistry first and then geology. And geochemistry is kind of hard, especially for people who don't like chemistry, who don't already know the periodic table. It's obscure material. Geology is very accessible, right? Here's some rocks, let's go out and bang on them, okay? It's visual, and what I found is when I started with geochemistry and moved on to geology, even though I thought that was more logical, because you have to make atoms before you can assemble them into a planet, before you can walk around on that planet, that's a nice logical flow. But the class didn't work very well, because after 5 weeks of geochemistry, the class was used to not understanding, and they never spoke up. When I flipped the class backwards and I started with geology, and then moved into geochemistry, it made for a much more dynamic environment. People got into the habit of participating because they could visualize and get the geology, right? Connected more to stuff that they learned in 6th grade, where the geochemistry material is all new. So you don't want to waste a whole lesson on review, but I think it's a good idea to start in a place that people are comfortable in their comfort zone, and then they start to speak up.
Well,
Yeah.
so suppose you're halfway through a class and you've done it fully the entire time, and everyone's terrified of saying anything, and you don't want to just waste the rest of the term. Do you have any ideas of how you would turn that around so that let's see, that's the last question.
Ooh, that's a good one, right? Because people do get into habits and they develop expectations. And the patterns that you set at the beginning of the term can be hard to break. Yes, here's something you can do. You can have to go on travel, or get sick, or have to be on a thesis defense, or something that removes you from the situation for a day, or a couple of days, or a week. And if you have a TA, let the TA teach the class while you're gone. Or if you don't have a as a stunt, it might work to do it intentionally. Another is, especially if you're dealing with a small number of students, schedule something outside the regular class time. Take them to coffee. Right? Coffee. Or especially if you're teaching geology, take them to the field. That doesn't work as well for other fields. So yeah, if you're feeling a barrier developing, it's getting formal, there are things you can do to break it up, I think. And the other is force the issue by assigning an oral presentation to the class. Just say, okay, next week, you guys are leading the discussion, whether you want to or not. As a teacher, you do have the authority to force people to participate. If they don't want to, you don't want to use it, but it's there.
So I have a question.
Yeah.
As you brought it up, it's only slightly off topic. So if you're gonna leave for some stunt or just a more valid reason, like you actually do have a talk that you have to give in New York, then what do you tell your TA? I mean, how do you let them do whatever they want? Do you try to mold them into your own? What do you do?
Well, so first of all, at least in GPS, we actually have an understanding that being the TA for a class should come with the privilege and responsibility to give at least one full dress lecture. Right? That TAing shouldn't just be grading, it shouldn't just be running a section. That doesn't work in every class, but it's a nice goal. So I suppose it would depend on the kind of class that I'm doing. If it's a lecture class, with a syllabus, probably the TA will know what the next lecture is and will probably give it as if they were me. In a seminar or reading class, right, especially where the students have done the reading and the students are coming in to discuss the reading, the TA is just there to guide the discussion and can do it in their own way, and especially if their way is a little more approachable than your way, that could be good. So, variable answers to that question. But do any other divisions have this notion that if you're the TA, you should actually teach?
Not really.
It's kind of a good one. Because you get to the end of graduate school, or end of a postdoc, and you're applying for faculty jobs, and you say, I was the TA for, or your letters of recommendation say, this person was the TA for my class, but if they didn't actually teach, that's not much of a qualification. So here's the most experimental thing that I do when I'm teaching a seminar class. Okay, the course description for GE 215, Advanced Petrology, says we will discuss amongst ourselves what we're going to do. The content of the class is flexible according to the needs of the students. In practice, what that means is I poll the students before the quarter starts for ideas. I take half a dozen of those ideas and I work them up into a draft syllabus. And then on the first day of the term, we vote. We actually, okay, here's 6 potential syllabi. Some of them I've actually taught before, and so it's completely worked out. Okay, some of them are just an outline, an idea, but put it all out there. And seriously, we vote. And some years I manipulate the voting rules a little bit so that I have some idea what the outcome is going to be. Some years, some of the students actually engage in voter suppression or other forms of manipulation. In the case of the 2008 version of the class, this one, trace elements, one of the students really wanted to do trace elements, and I really didn't want to do trace elements. But she got the outcome that she wanted in the election, and that's what we did, we did trace elements. So literally, at least twice, when I did trace elements and when I did diffusion, I made up the class as we went along. I sat down and I said, okay, we have 10 weeks. What do you need to know about trace elements? I made an outline and went out and either looked for reading that I thought was appropriate or actually asked the students to suggest reading that was appropriate, and we put the class together and we ran it. And it's a little nerve-wracking, not not to be secure in knowing what you're going to do for the whole quarter, not to be secure in being way ahead of the students and having a complete body of knowledge prepared, not to be secure in having so many words packed into your PowerPoint slides that all you have to do is get up here and read them. Right? It's a little scary and it's a little risky, but it's also very cool and it's rewarding. So the reason that I do that, okay, first of all, I've already mentioned this. Okay? If the students want to learn what you are going to teach them, they are going to put more effort into learning it. And this is very helpful. This is why it really sucks to teach required classes. This is something that we all have to do at some point in our lives. As long as we go to schools that have course requirements, we're going to have to teach required courses. You know? And sometimes they're only required once the student has made a choice, like they've declared a major. Sometimes they're just plain required. So the instructor for Biology 1, which is required of all the freshmen here, complained to me that as the instructor of Geology 1, which is a menu class, I have an unfair advantage. But once you get away from required classes that students have chosen to take, they still usually are choosing to take the material that you, the professor, think should go in the class. Right? If you can go beyond that and let the students help choose the material as well as the title of the class that they're taking, then you really have set the foundation for engagement by the students, for involvement, for a collective exercise. Okay? And this point, I suppose, is controversial. Okay? Above a certain level, so there's a caveat to get me out of your question. Students actually know what they need to know, even if they don't know it yet. Okay? If somebody is saying to themselves, all right, I've got this research project that is going to be my thesis, and I need to learn the following areas of material, well, I have a pretty clear idea, even if I haven't learned the material yet, what material I have to learn. And so, at least with graduate students, this works, that you can get a group of them together in a general broad subject area like igneous petrology, and say, okay, to do your work, what do you guys need to learn? And then let's do it. That is going to break down if you get to too heterogeneous a population. You know, if you are dealing with a class with 20 people in it, unless all 20 of them are in the same research group or closely related research groups, they probably have different things that they need. And this is the problem with voting as a system of choosing anything, right? There's a winning majority and then there's a losing minority. So you have the challenge immediately in this system of convincing the losing minority that they also want to learn this material. That is a challenge, right? But so far it's not, to me, been an insurmountable challenge. Okay, and so this this may not be for everybody, but I recommend trying it if you have an opportunity. Okay, if you get a group of students and those students have some idea of their direction in life already, right? You don't have to sit down, you know, a year and a half in advance when the course catalog is written and say, this is what this class is going to be, this is the syllabus, it's posted, it's fixed, I can now spend the next 18 months preparing every lecture in great detail. You don't have to do that.
So how do you, I really like this idea of kind of involving students in what you do, but how do you deal with them wanting to do topics that they maybe don't have enough background for? Because that happened in something that I was teaching. I was like, oh, you guys should pick some topics, and then I tried to teach it, and I realized I actually didn't know a lot of stuff that they needed to know, and then it was hard to get to the topic because you know, run out of time and stuff. So.
Well, so that's where the faculty input comes in, right? And why you sometimes want to give yourself, you know, a Supreme Court to review the results of the recount of the election. But the if indeed there is background material that the students need to get to the point where they can learn what they want to learn, then spending the course on the background material is constructive, right? It's what they need. In this case, they might not actually know they need it because they haven't gotten the background material, but I think that's okay, especially if you can work in tastes and tidbits of where it's going and what the background material is for, right? And this, I mean, that's true at any level, that you're teaching some body of material, the top of the iceberg may be invisible while you're climbing your way up through the bottom, swimming your way up through the bottom. But it's giving some glimpses of the top of the mountain of what this is all about is very important at any level, unless they actually are standing on the mountain and saying, how do I, unless their avatar is standing on the mountain and they're saying, how do I climb up to that point? All right, so for reading classes, for classes where the basic activity is everybody's going to read a paper or a group of papers and you're going to get together and you're going to talk about it. This is a common modality of studying material, right? There are many classes where there isn't a textbook, right? Beyond, freshman year, you may not have a textbook that covers the material that you want, or covers it at the right level, or covers it the way you want. And so, this doesn't feel radical to me at all, because I've never taught from a textbook, but I suppose to a lot of people contemplating the idea of teaching without a textbook seems dangerous. But it's actually very liberating. You don't have to follow the order of the table of contents that some author thinks is right. You don't have to use the exercises that author provided. You get to design the class, or you and the students get to design the class and put the material in. But that means you have to find stuff for the students to read, and that often brings you up against the challenge that the key papers may be completely unreadable, right? I think if you're trying to teach general relativity, and you give them Einstein's original papers in German, right? Or even in English, they're not going to get very far, right? And there's just a lot of, frankly, badly written papers that turn out to be really important. They have important content. The experts understood the point of the papers, but you can give them to students and they're not going to get very far. And to some extent, you get around that using review papers, which are written specifically at a meta level to explain the content of primary papers. But those, they can be really big, really long, they can be pitched to the wrong audience. That's not necessarily the solution. What I like to do is try hard to find, among the primary scientific literature, the classic papers that really are well written and do a good job presenting the material at a level that the students can understand. And it's not easy, but it's an important goal. And it's one example among many of what I think is the basic skill, one of the basic skills of teaching, which is to remember what it's like not to know stuff, right? Once you've learned material and you've mastered it, if you're going to teach it, you still have to get into the mind of a person who doesn't know and hasn't mastered it. So you can read a paper and say, oh, this paper is perfectly clear to me, but it wouldn't be clear to anybody else. So choosing papers is a part of that activity of thinking to yourself, if I were coming to this paper for the first time, what I read it, would it make sense to me? The acid test for reading, the way you know that paper is readable, is depending on your own personal sleep schedule. Start 10 minutes before you expect to go to sleep and read the paper. And if you find that you're closing your eyes every paragraph and not getting through it, the paper is not compelling. If the paper is compelling enough to keep you awake, it's compelling enough to engage a student. And then teach students how to read material that they don't understand, right? And reading material you don't understand, if you're going to understand it, requires you often to stop at the first hurdle and say, I don't get this. Highlight it, come into class and ask about it, okay? And students shouldn't be shy about using up lots and lots of highlighters. Highlighters are cheap, okay? And especially if you're teaching a class with the spirit of we're all trying to understand this material, not we're trying to read this many papers and get to the end, you want the students to be comfortable asking those questions. So you can force that issue if you're finding that the students are not asking questions, but you think they're actually not getting the material, or you look over their shoulder and not very much stuff is highlighted, right? Force that by saying, okay, everybody needs to bring in 3 questions about this paper. then you get past the shyness of somebody not wanting to ask a question about a paper. I'm actually planning to do something very much like that in GE1, this freshman class that I'm teaching next in the spring quarter. I'm using a new book. It's called How to Build a Habitable Planet. It's a fairly engaging title and a fairly engaging subject. And the first edition of How to Build a Habitable Planet came out in 1985, and it was this little book, and it was a real classic, but it's very hard to get. So the second edition just came out. It's 3 times bigger, and the editing is terrible. It is riddled with mistakes. And so when I first started reading it, I'm like, I can't use this. It's riddled with mistakes. And my second thought was, I'm going to use it anyway, and I'm going to assign the students to find the mistakes. And that's how I'll know they're doing the reading. Got to find 3 mistakes in every chapter, and if you find a mistake that I missed, then it's double credit. And a lot of them are easy mistakes, you know, units that are wrong, and grammar. You know, there aren't any real deep, serious science errors in the book, but I think that's a strategy that you can use. Yeah.
So if you ask them to identify things they don't understand, does that make you the answer person?
I suppose that depends what you do when they bring something up. You can say, anybody? Let's see if anybody else wants to. Or you can try to tease it out of them. Maybe they do understand it and they just haven't made connections. Right? So you can get all Socratic on them and ask them questions in response to their questions. And this is important actually. When we have graduate students come up for their oral exams in GPS in their second year, we very often find that they are missing the connections between silos, between material they learned in different classes or in different times in their life. And you know, even if it's obvious to us that this material is all interconnected, it isn't always obvious to them. And so when somebody doesn't understand something they read, it may be that they're just not putting the facts that they know together in the right order. So I think often you can lead a student into figuring it out without just laying it out. And if you can, that's always the best thing to do. Because then they're learning how to learn instead of just learning. And then in the seminar situation, once you have laid the foundation, hopefully by making sure everybody is comfortable speaking and making sure that the students are engaged with the material because they helped pick it, and that they have done the reading and thought about the reading. The last point that I want to put out there is you want the students to participate, but you want that participation to be helpful for everybody, okay? Not just the student that is participating. And so, you know, when I'm doing a reading class, there will be a discussion leader for each paper. It's their job to present the material to the class and at least get the discussion going. And this can be very inefficient. Right? If the student who is presenting the material has not thought about the material or does not get the material, there may not be very much content in their presentation beyond, okay, they scanned the figures and they put them in a PowerPoint for you and they can slap it up on the screen. So that means, you know, the other students aren't learning very much if the discussion leader isn't bringing very much to the table. So the alternative, the obvious alternative is just, okay, the professor presents all the material, but I think this not only misses the opportunity for a student to present that material, but it discourages the other students from presenting material in the future. So the ideal way to run a reading class is there is a student leader for the discussion. The professor is there to do a couple of things. One is to guide the presenter who may not have a good overview of all of the material towards what part of the material is important.
Do you do that in advance or during the class?
I would rather do it during the class because I'd rather the student try to find the relevant bits for themselves, and if they're not doing it, then pull it out. So without being overbearing, without interrupting too much, you can steer the discussion towards whatever part of the assignment is important. Okay. You can ask the presenter questions. Hopefully the other students will also ask the presenter questions, but that doesn't happen that often, right? And as with your example of when a student brings up something they don't understand in the reading, the goal of the question should be to draw the answer out of the student to help them to make a connection, to understand what their reading is about as they're presenting it to the class. And then, unless the reading is really ideal, and it never is, right, the professor is going to have to fill in some gaps, some stuff that's not in the reading, some stuff that nobody in the class got because it's badly written in the paper, and everybody has it highlighted. Okay. So we've done an okay job here getting you guys to participate, but not as good as I would like, not up to my standards. Okay. This has been 90-10, and a good reading seminar, or even without reading, a lecture-based seminar of 10 people should be 50-50. So, if you want this small PowerPoint of 12 slides, I posted it at this address. If you're too lazy to type that address, you can aim your phone at the QR code, which makes for a great self-referential file. Because if you point your phone at this QR code, it'll bring up a file that contains this QR code. And somebody else can point it. Anyway, questions, discussion, other ideas people have that maybe you guys want to share about what you think a seminar class should be. Right?
So if you have a small class, say like 10 people, and you have 2 or 3 students that are really sort of outstanding, they're really on the material, they do the reading, they really engage in the discussions, how do you stop them from sort of dominating, but without kind of punishing them, as it were?
That's hard. On the one hand, you may have to accept that as inevitable. Those are the students who are going to really get the most out of the class. And if the others aren't bringing it, well, there isn't necessarily that much you can do, but hopefully they will learn from observing the strong students. The other thing you can do is group the students. Right? Take a strong student and a couple of the weak students and compel them to work together, or encourage them to work together, or set up a situation where they want to work together. Another approach is turn taking. If everybody is going to take it in turn to be a discussion leader, and it's just not an option for them to decline to be a discussion leader, then at least they're participating. I had another version of GE 215, the one I did most recently, was not a reading class, it was a lecture class, but the skill that we were trying to learn involved graphical construction of thermodynamic phase diagrams, and I just spent as much time as was necessary handing the chalk to people and letting them go up to the blackboard and draw these diagrams. It took a lot of time, but hopefully everybody came out of the class with a real visual grasp of how these diagrams work. And if I set up the blackboard with 4 or 5 diagrams in parallel so that everybody's working on the diagram, okay, one student finishes in 3 minutes, but we have the time and we have the patience for the others to keep going and for everybody to help them. So yeah, students with different backgrounds and different levels of commitment and different abilities, that's a part of teaching. You do what you can. I don't have a magic bullet for that. There's some ideas.
So what's your process for helping people to figure out how to read papers in the way you want them to read papers for this class? As a researcher, you go in looking for little tidbits, you're hunting. But in a class, you're sort of trying to be more holistic.
That's an interesting point. So in here's once a week, the students read a paper, professors read the paper, we get together and we talk about it, and they see how it is that us professors think about papers. In a class, unless you're going to sit there sort of and read a paper aloud to them and say, here's my process, which I've never tried, it's going to come down to the first couple weeks when students are reading papers and coming in to discuss them. Take some time to talk about how to read. And when you're guiding the discussion and you're helping the students find the relevant bits to present, you're also helping them think about finding the relevant bits in the papers in the future. I guess one thing you could do is take a model paper and highlight it yourself. Assuming highlighting is even your way of reading a paper, that's not necessarily the way everybody does it. But then, hand it out to them, annotate it as an example of, okay, I read this paper and this was the process that I went through. Here's my marginalia. It's at least a written record you can give them of, here's the scan pattern of your eyes when you read a paper.
Well, I guess I ask this because there have been a few times through my education where I've noticed when someone just makes it explicit what their thought process is, I can just fall right into that and I get much more out of the ensuing experience. And one recent example is my advisor saying, like, I'm a little dissatisfied with how in general, these lab meeting presentations are going. Here's the structure. I really want to make sure you hit these points of where you were last time. What changed? And you're bringing the salient points of what you've done in the last 3 to 6 months, whatever it is. And then you wrap up with this sort of thing. Because everyone can do stuff their own way. And if your goal is something very specific, so in lab meeting there's a very specific goal. In reading a paper, just generally, like, what are the tools you need every time you come to a paper? What's your main question? How much should you care about the methods and other things like that? Is there a way you see that could be made really explicit and also with a model like you're talking about, and how?
I think you've just done it. I think that's great. And that I haven't really thought of it that way before, but that is an important part of a reading course. It's not just what you read, but it's how you read. So, yeah, any guidelines like that you can give, if you've done enough self-exegesis to understand your own reading process, then perhaps you can explain that reading process to somebody else. That's the cool idea. I don't have to think about what my reading process is.
Well, it sounds like it comes out just in discussion, but somehow formalizing it.
Yeah, but yes, you
Are
can
you
make it
saying, like,
explicit.
make sure you know why they even did this
Yeah,
research.
I would tend to
Or
assume
else
that
it's not useful.
by the time somebody gets to graduate school, if I say, okay, read this paper and come in and present it, they know what I mean, but that's not necessarily true.
Okay, so I don't think I've heard anybody disagree with you yet, so I'm going to be the guy to come out and disagree. Not with any of the content. I think all of the stuff you were talking about was dead on, but one aspect in particular, that this is only applicable for seminar or small classes. And so I really like to believe that this is possible in a larger lecture classroom. So part of it is like the organization of the room and the organization of the class. So in a hall like this, we're all aimed at you. We're all looking at you. So you are the presenter and we're focusing on you. If you want interaction between students, we have 2 people who can talk to us. Like turning around and talking to the people behind us is awkward. So a setting like this discourages that kind of interaction. But I think as you get into larger and larger class sizes, in order to keep that interaction and that discussion happening, you have to start to let go as a professor and give the students more leeway, give them more interaction amongst each other in order to get that same effect. So I think all of the ideas and the philosophies, the strategies that you were talking about were right, but I don't think it's only applicable for small seminar classes.
That's an excellent point, and I agree. I'm just not the expert on translating these ideas into big classes. I've yet to have the opportunity to do it. I'm going to try it. But yes, there's a lot of research and new ideas coming forwards in teaching about the importance of making it interactive and participatory and something beyond simple professor standing in the front and blabbing, and that's true at all scales of classes. So, sure, yeah, take what I'm saying here and see how it can be applied to whatever level and whatever size of class.
Can you talk a little bit about grading and evaluation?
So
maybe the answer is you give everybody an A that shows up. But what do you do?
yeah, well, if you can grade pass fail, so that you're basically doing that but not in an inflationary way, that may be the appropriate standard for evaluation of what you're doing, right? That you're everybody who shows up by showing up is learning the material, and you're not explicitly evaluating learning, so you don't have criteria to grade. So I was quoted, caught saying to my class this quarter on the first day of class, I think grades in graduate school are stupid, nobody's ever going to look at them. And that's more or less true. Okay? Look, if you have a PhD from Caltech, nobody's ever going to read your transcripts. Okay? And no, that's not true everywhere, and that's not true at all levels of teaching. You often will be teaching students who really do need to care about their grades. It makes a difference to their future. If you can avoid that, please do. Because at a certain level, especially when the point of grading is to sort the students by ability, it's obnoxious and it's puerile and it's no fun. When the point of it is kind of on an absolute standard to evaluate whether the students are learning the material, that's useful. In a seminar class, you get that sense from the way that they are interacting with you, the way they're reading the papers, what they have to say in class. So you can assign a research paper if your department requires that at the end of the whole thing you have a grade and you need some material, some criteria on which to grade them, you can assign a paper like that. But honestly, I would rather, as much as I can, remove that aspect of that grading and evaluation aspect from the whole experience and just try to that's okay, that's utopian, but that's where I'm coming from. If it really is just going to be a reading seminar and participation class, it's qualitative, but the level of somebody's participation is a measurable experience, and it's something you can grade on. And you can tell them right at the beginning, okay, you're going to get a grade in this class, and your grade is going to be based on your class participation and your engagement with the material and the extent to which you are helping your fellow students learn. And then whatever your own personal sense is for an appropriate curve, use it.
I mean, to go back to what you said earlier, people come from different cultural and educational backgrounds. And if you're grading a level of participation in discussion and how much you've helped other people learn, how much you've, successfully gotten the point of the thing you're presenting, it seems like that's really hard.
For some people it is. For some people that's going to be very new. They don't have to take the class. That comes back to, it's best to teach people who want to be taught in the way that you're teaching them. So if you're upfront about what the class is like, people who don't need the class to satisfy a requirement and don't think it's going to work for them, can go take a different class. But yeah, that's very true. There is a real transition in thinking style and in learning style. There are lots of transitions in life, but from undergraduate to graduate school, right, should be a really major transition in the way people approach their work and their behavior and their engagement with the material. Students who don't make that transition really get into trouble in graduate school. They think, okay, I'm going to take my classes, the professor is going to tell me what I need to know, I'm going to take the test, I'm going to pass the test, I'm going to get an A, I'm going to get my PhD, and I'm going to get a job. That isn't what graduate school in science should be, right? And so a seminar class like this actually is a really good opportunity to show the students how you think science should be done, how you think they should be thinking about the material, how to approach it in a mature way that's different from the way undergraduates approach it. That's another thing you can do with a class like this. And also, the student who wrote down when I said grading is stupid, the other thing he wrote down that I said in that first lecture was something to the effect of, you will not be permitted to hide. What I was saying is, the way to be a successful graduate student in a department, especially a big department where there are lots of graduate students, right, is to make yourself known, right, is to get out there and talk to professors and be at the seminars and be part of the community, right, and sitting in your office doing your work is a lousy way to be a graduate student. It's a lousy way to be a postdoc. It's a lousy way to be a professor. I can think of really smart people who did really good work and nobody ever knew about it. Not that you should be out there advertising all the time, but science is interactive. And so one aspect of encouraging participation in the nice, comfortable, closed boundary environment of a seminar is it's a little model for this idea that I'm trying to get across, that students should get out there and get in people's spaces and get themselves known and be part of the community.
One of the unusual things about Caltech is we have a lot of undergraduates who take our graduate courses, whether it's reading courses or else. How do you deal with students that are at the undergraduate level when you're trying to teach a graduate level of mature thinking?
Well, so far in my experience, they end up pass-failing the class most of the time. Not always. Some of our seniors are operating at the level, that graduate students operate at in general, and they're ready for that kind of thing. And then of course, we said this concept of a seminar extends all the way down. We have this freshman seminar program that we're rolling out, where I think even at the freshman seminar level, you're going to get more out of it being a seminar if you're encouraging the students to participate as they can. I guess if you have the opportunity to control who gets into your class, and in general, if you're teaching a graduate class, an undergraduate is going to require a signature to get in. You can try to make that decision whether you think they're going to benefit and whether the whole class is going to benefit from having them there.
Yeah, I was a physics major at a liberal arts school, and all of our upper level classes, both in physics and other subjects, were seminar-based, seminar format. And I felt like it worked great in, say, English or economics, but frankly it didn't work that well for me in physics. Like, there was too much student presentation based, and I felt like the professor wasn't fully utilized, even though they would chime in at times. And I guess I would contrast that to my advisor here at Caltech teaches a first year graduate course, which typically has only 2 to 5 students enrolled probably, and it's pure lecture, like no student participation whatsoever. And I actually like that better. And I was wondering if, in your experience, any material, if you do it right, is amiable to the seminar format, and sort of, because if you're blessed with a class that only has 5 to 10 students enrolled, should you always format it as a seminar, and is there a way to do that in a really effective way?
No, I think you're right that there is some material that, even if it's a small class and specialty material, benefits from a conventional pedantic presentation. Yeah, no, I'm not going to stand up here and say this kind of approach is the only approach that you need to have in your toolkit, because I don't always use it, and you can't always use it.
But if I can add my own opinion to that, my favorite classes in undergrad, I had 2. One which was a normal seminar class where the professor taught everything, and the other one was a completely student-led class where the professor would get up on the board. It was a real analysis class, so it's very math physics oriented. And he would just write the theorem and he'd say, does everybody understand the statement of the theorem? And then he'd wait 2 seconds and then he'd say, would anybody like to prove the theorem? And then he'd just wait there. And then we all thought about it, and we all thought like really, really hard because we wanted to prove the theorem. And I'm taking a real analysis class here, and it's a graduate course. We're probably getting through 5 times as much material. but I can't go to the class because that man blazes through material like he's eating candy. And it doesn't work for me as well. Like, that was really my favorite class in undergrad because I got that material like down to my bones. And that's how I prefer learning. Even though I had this great experience with a physics professor who just came up there and taught, and he went fast and he went awesome and he went hard and detailed. So I like both. I'm just saying you can do everything. It's up to you. There's pros and cons in either way.
Yeah, thanks. Good insight.
That's bold. I mean, kind of following up on Noel's question. Let's say you get to teach a seminar class, but it's an undergraduate required course. You can't tell people not to take it. You have to give them grades. The grades matter. You know, I mean, I like what you're saying about teaching grad students, you know, about motivation and grades not mattering and so forth. But if that's not the case, how do you get people to show up to class, to do the problem sets if you assign them so they need to engage with it outside of class? I mean, is it realistic to be able to inspire them to do that?
Yeah. There are several ways to get people to show up in class. Okay? One is to make their grade dependent. The other is to present material only in lecture that is not available anywhere else. Both of these are sort of punitive approaches. And the other is to make your lectures interesting and dynamic and fun, and have enough personality, hopefully, that people actually want to come and watch you perform. And that's skill. Not everybody has that.